Hey gang, week 6, day 5. Finally Friday. Alright, this week's reading passage is called Long-Term Monitoring of the Hudson River. And it is by the American Museum of Natural History. And this section goes from page 629 to page 636. Alright, Long-Term Monitoring of the Hudson River. A puzzling reversal. In 2005, 14 years after the first sighting of zebra mussels in the Hudson River, Carey Institute scientists noticed an unexpected change in the river. Zooplankton had returned to the same levels as before the invasion. Why weren't the zebra mussels eating as much zooplankton? Then the scientists observed a change in the zebra mussels. I think I said zoo mussels. Zebra mussels they were collecting from the river. Zebra mussels are grouped into 3 sizes: small, less than 10 millimeter, medium, 10 to 20 millimeter, and large, more than 20 millimeter. While there were still many zebra mussels in the Hudson River, the overall number of zebra mussels was slightly declining, and they were on average much smaller. Populations of the largest or oldest mussels were declining greatly. Zebra mussels can live 6 or 7 years. But now it seemed that most were dying after only 1 or 2 years. Adult zebra mussels had less than 1% chance of surviving a given year. The impact of the zebra mussels invasion was changing. If there were fewer large zebra mussels, it made sense that there was more zooplankton. That's because large zebra mussels feed on bigger food particles like zooplankton. Smaller zebra mussels can eat only small particles like phytoplankton and bacteria. These new effects rippled through the food web. As zooplankton rebounded, so did native mussels and clams. Scientists anticipate some fish species will rebound too as their food supply increases. Scientists don't know exactly what caused the decline in large zebra mussels, but they do know that blue crabs were eating some of them. More time, more data, more answers, and more questions. By monitoring several aspects of the Hudson River over many years, Carey Institute scientists were beginning to answer their original questions. How might a zebra mussel invasion affect the Hudson River ecosystem? Early on during the invasion, zebra mussels survived, thrived, and had a huge impact on the ecosystem's food web, just as scientists had predicted. But almost 20 years later, the number of zebra mussels has declined overall. In parts of the ecosystem, such as the number of zooplankton, native mussels and clams have started to increase. But is this the end of the story? Or have we just seen the first 2 stages of an invasion that might have 3 or 4 stages or more? As their data grows, the scientists are able to track changes in the river, whether from pollution, weather, sea level rise, invasive species, or human activity, and to pose new questions. This broad approach also puts Carey scientists in a unique position to investigate future changes in the Hudson River ecosystem. All right, vocab's next.